In MoonBit, the is expression tests whether a value matches a specific pattern. It returns a Boolean value and can be used wherever a Boolean is expected. The is expression in MoonBit introduces pattern binders that can be used across various contexts to directly access matched values in complex conditions. In this function, the parameter is an option integer. The syntax is similar to Rust's if-let, but with a slight difference. For example, using sum, the content inside the option can be bound to a variable and used within the if block. In the if statement, an additional condition can be added, where the variable I from the previous condition is accessible. However, in the else branch, I is not accessible and will result in an unbound error, as it is only available when the condition evaluates to true. MoonBit now supports Unicode safe pattern matching over prefix and postfix of string. This update introduces the use of array spread syntax for constructing strings. It also allows string destructuring in a similar way. Let's first look at how we can use array spread to construct a string. We can declare a string S, and the square brackets represent our view operation. Here, we are creating a view of S that includes Unicode characters from the 1st to the 6th, excluding the 6th character. Then, using the newly introduced array spread operation, we can easily construct a string where the first element is X. We use ... to spread the original string S, and we continue by spreading the view we just created. Finally, we can append another character to the string. This allows us to easily construct strings through array-like operations. Since the implementation compiles to a string builder, it's also highly efficient. You can test this by running the main function, and the result should display the string with emojis handled correctly. Next, we've enhanced string pattern matching. Previously, we could only match strings using string literals in a match expression. For example, if I write a new function called matchString that takes a parameter of type string and returns a value of type unit when matching S, we previously could only use string literals. Now, we can use array patterns for destructuring strings. This means we can extract characters from a string. For example, we can get the first character and put the rest of the string into a view by ... rest. Then we can print C and rest. Here we can type something not hello, for example, world, and click run. We can see the output here with the first character W and the rest. Here for the first C, we can use char literal or even range pattern. For example, we hope it to match a small letter among A to Z. You can also type any emoji. This works well. You can use as C to bind a variable for A to Z. Is expression applies for array pattern as well. For example, when you are working on a string like let S equals to something, you can check if the first character of a string is a plus or minus sign with if S is. If it is, the program enters the if branch. Otherwise, other processing can occur. MoonBit X introduces the sys package, which handles system operations like retrieving environment variables and command line arguments. The usage of this package is straightforward, similar to other packages. One function allows you to retrieve all environment variables from the system. You can also set environment variables and unset them as needed. The specific usage is clear from the black box tests. The package provides file system operations in MoonBit, such as reading, writing, checking whether a path exists, and creating directories. For file operations, we offer two options. One for reading and writing UTF 8 bytes, and another for higher-level string operations. The recent change involves adding error handling to these interfaces, as file operations are prone to errors. Previously, the native implementation of this package used a custom stub C file in the backend. Recently, we've moved some of these interfaces to the compiler's built-in C runtime via FFI, eliminating the need for the separate stub.c file. Let's take a look at the black box test. The test is straightforward. First, it tests writing bytes by converting a variable, content1, to bytes, writing it, and then reading it back and to verify that the original content is preserved. For directory operations, it reads all files in the current FS directory. We are currently reorganizing some of the string-related APIs. Previously, many string operations, such as indexing, were performed using integers, and the string was encoded in UTF-16. This created ambiguity when accessing elements, whether you are retrieving a code unit or a Unicode character. Our goal is for the MoonBit string package to provide more Unicode-safe APIs. So, we will gradually deprecate APIs that expose UTF-16 implementation details. During this transition, some string operations may be deprecated, so they may not be stable. Unless you are building a highly specialized and performance-focused string library, the recommended approach for working with strings is to use the ITER method or pattern matching. These methods ensure Unicode safety. For example, with the ITER method, you can iterate over a string using a for loop, such as for C in S. This approach will correctly handle each Unicode character. If you use ITER, you can print each character one by one. It will correctly process and display each Unicode character, ensuring that all characters, including emojis, are handled properly. MoonBit IDE added code action support for filling in missing cases and pattern matching automatically. Second, MoonBit IDE will also provide inline auto-completion for all cases and empty pattern matches. For MoonBit docs, we added a new error code index listing every error code, example, and suggestion for your reference. Many entries are still incomplete, and we would appreciate your contributions.